Hello, I'm Craig Savage, and today I'll be talking about maps with R, static, dynamic, and mapped. And I'll explain what I mean by those three things in case you're curious. So as an introduction to this talk, it was built with a program called Quarto. It's specifically a Reveal.js presentation, so while these are slides, this isn't PowerPoint. The fact that this isn't PowerPoint will be important when I get to the dynamic visualizations. It's similar to a Jupyter Notebook, if you've used Jupyter Notebooks before, or Google Colab, and it's more so a successor to R Markdown. One of the big differences with Quarto, you can use other programming languages such as Python, and it has a bit more flexibility. It's a combination of text, images, and code. One of the advantages to Quarto is some of the tools for using code are a bit more advanced. Now, the code is available on GitHub, and because Quarto is plain text, this entire presentation, including the text for the slides, the images, and the code results are all available. You can get it from GitHub there. I'll also put a link in the description. So if I talk about the data I'll be using, there are different geographical structures used by the Australian Bureau of Statistics, or ABS, and the maps you use will depend on which underlying standard or underlying structure you use. So you can use things like government boundaries to segment things by country, by state, by county, etc. You can use electoral boundaries. Note that in Australia, federal boundaries and state boundaries are different. So if you're going to be using some electoral thing or electoral structure because you are speaking to a particular representative, make sure you have the right electorate. There we go. Postcodes. Now, a problem with postcodes is sometimes they can be disjoint. So there are postcodes in Australia which there's some over here and some over there. Postcodes can cross state boundaries, they can cross government districts, etc. And then there's something called statistical areas. And so if you look at the figure, there's the blue kind of line where at the top you have Australia and at the bottom you have mesh blocks. Now these are designed to be statistically useful, so it's hierarchical. So the country is divided into states. The states are divided into statistical areas level 4. Each statistical level, area 4, is divided into level 3, and so forth down to mesh blocks. And so this way you don't get any overlap, everything's contiguous, and they're built to have similar properties so that each SA4 is roughly the same size in terms of population. Now, one of the nice things about doing this with R is all of those structures are available as a GitHub package from WF Mackey. So go over to WF Mackey's page and give them some love. Now you can install them. One thing to be careful of is because there's so much data, you need to, or you may need to increase the timeout because you're downloading everything, and then you can use the remotes package to install this via GitHub to get all the shapefiles in one go. This will save you a lot of time. Here's an example of the data I'll be using. This is payroll, jobs, and wages. It's got some quirks to the data. First off, it's in Excel. There are different worksheets at the bottom, which you can see the tabs. This is the SA4 tab. There's also an SA3 tab. Another wrinkle to the data is the statistical area 4 is actually two different data elements put together. So there's the code being the number. So for example, Hume is 204. I'm going to need to separate those out. The data are indexed so that the 14th of March 2020, everything is 100, so that as you go in time, it's relative to a baseline that the 14th of March is scaled for each SA4, so that while, say, Hume and Inner Melbourne are both 100, the ratio between the two is unknown. So this is for SA4. There's a similar sheet for SA3 and greater capital city statistical areas. Other annoying things are the information at the top. I'm going to need to skip a few lines in order to read in the data. And then there are all of these columns from the 4th of January 2020 until the 15th of October 2022. Each of those dates has a column of their own data. So if you pull this up in Excel, there's quite a long scroll to the right. So I'm going to read in the data. So with my Excel file, using read Excel to get the data based on the sheet, the SA4 sheet, and skip 5 says start reading the data after 5 lines to get rid of that header. Wrangling the data, I'm going to start with the raw data, rename state from state or territory just to make it shorter. I'm going to look solely at Victoria because I'm Victorian, and then I'm going to separate the statistical area level 4 into its component parts. That is the code or the number and the name or the text. And they're separated by dot and space. And if there are extras, so if there's extra dots or extra spaces in the name, I want it all to merge in. And then I'm going to pivot it to so-called tidy my data. That is to say, rather than having information date by date, I want to make it a long data set so that I have a column with all the dates and all the values so that it's long rather than wide. Now, because these are dates in Excel, you need to do some fiddling with it. And then the index, in case there are any missings or NA, I'm just ensuring it's numeric. For the geography side of things, I'm going to be using the ABS Maps data package. So this is using the SA4 information from the 2021 census, and I'm going to construct just the last data by a join between my geographic data and then the last element of my jobs data, selecting only the code, which I'm going to be used as the join key, the date, which I'm only going to have one for now, and then the index. So once that's all done, this is an example of the head of my data. The date and the index are coming from the Excel file. The SA4 code 2021 is my join key, and everything else is coming from the ABS Maps data package. Now in particular, we have this funny variable called geometry, which is a simple feature. You can see here that it's multi-polygon, and I'm going to be using that to define my map. So if I use an SA3 or a postcode, the exact shapes for my map are defined in that geometry. So now I want to talk about static maps because sometimes your stakeholders want PowerPoint. So I'm going to be using ggplot, and there's a geom_sf code that uses simple feature objects, so I can utilize the geometry from my geographic data, which is provided by ABS Maps data. So the way I'm going to do that is I'm going to first initialize a plot. I've created this variable called static map, and if you just call ggplot with your data, nothing happens. In order to use ggplot, you need to augment it with these geoms, such as geom_sf. And here I'm saying I want the fill of the map to be scaled according to the index. Geom_sf has the property that it will look for a geometry field in your data and use that to define the boundaries of your maps. I then use theme void, and what this does is it removes the axes, so I won't have a latitude and longitude axis. I'm using a custom color palette. I'm using yellow, orange, brown, and then add some labels, a title and a subtitle. And now if you just run that first part, in R, if you assign something to a variable, it doesn't display the result. So if you just run lines 1 to 6, it will create this static map variable, but it won't display it automatically. To get the map to display, I then call static map, and I get this. So the color scheme is, again, yellow, orange, brown. Yellow is a bit more like white, or kind of a beige color, but it comes up like this with the index color bar legend on the side and everything else. There's nothing I can do with this, it's static, so I can't mouse over I can mouse over things, but I don't get any additional information. I can't zoom, I can't pan, but for a static map, this is a good place to start. So now I'm going to be talking about building dynamic maps, which in my opinion are a little bit more fun. So I'll be using the leaflet package in R, which is an API to the JavaScript library, leaflet.js. So if you've used that before for mapping, it's going to be very similar. There's just a little bit of syntax differences to align your information in R with the appropriate calls to leaflet.js. Now there are some things that other plotting tools do automatically, which I need to specify in leaflet. So I'm going to create a palette, a color palette, in this case numeric, and I'm still going to be using the yellow, orange, brown, but I need to give it the domain of values that I want it to consider, and by default ggplot reverses it, so that brown is at the bottom, not the top. And then the overall code is very similar to ggplot. I initiate a graph with leaflet, or a map with leaflet, and give it my data. If you just call this, nothing happens. I need to go through and now add polygons. So here I'm going to make polygons where it's black lines outlining my geography with a void of 1, so I can make that thicker or thinner. Now label is new, and I'm creating that as the paste between the name of the SA4 and a rounded value of the index. The fill color, I'm using my palette, and I'm saying to color it according to that palette with the fill opacity so it's somewhat translucent. I then need to add the legend manually, like this, again utilizing the palette I created above and the values of my data, the index value of my data. As before, if you assign something to a variable, it doesn't display it automatically, so here I call it, and that should give you something like this. Now, unlike ggplot, if I mouse over things, there's that label information with the name of the SA4 and a rounded version of the index. I can pan this, and if I want to get more information on something like the Melbourne area, I can zoom in. And so it gives me this more dynamic approach to mapping, where if I want to call out certain information, I can customize that label. I can zoom in if I have some very small areas. Victoria, like many urban areas, in Melbourne, you can get some very fine detail there and some very broad detail out in rural areas. So the ability to zoom can be quite handy if you have a finer geography such as postcode or SA3, SA2, etc. Now with Leaflet, I can also access auxiliary information from the internet with these provider tiles. So here I'm using cardodb.positron, which has taken my latitudes, longitudes, and put it in context. So here I can see that this is Victoria. I can see Melbourne labeled in larger font here, and some other regional cities like Geelong, Warrnambool, Wangaratta, etc. And because this is dynamic, when I start to zoom in, I can get more detail. So roads are starting to appear. Zooming in further into Melbourne, the different satellite cities of Melbourne appear. Zooming in further, I can get individual suburbs of Melbourne if I keep zooming in. So St Kilda, Toorak, etc. The city grid starts to appear, etc. There are other forms of provider tiles. cardodb.positron is a kind of neutral one, but you can also use like world imagery, where here I have satellite data. And again, if I zoom in, I can get more features. Zooming in towards the CBD, you can start to see buildings. We can see parks, the river. Zooming in further, we can start to see the stadia, the Albert Park Lake, and some other real-world images of the area. Something I will caution you about this, although I think this looks very good, is because I'm using color, the color of the world image is a little bit different. So for example, if I look over here in the alpine regions of Victoria, the coloration of the alpine region is different. It's a darker green than other areas. And as a more extreme case, if I were to look at the entire country, any color I've overlaid on the red center may appear different than something overlaid on green. So if you're using color, be careful how that's going to interact with your auxiliary information. So the final type of maps I want to talk about is mapped. And here by mapped, I don't mean map in terms of geographical information and data visualization, but more of a mathematical mapping. So here it's using the per function map. And what the per map does is you give it a function and a vector or a list of inputs, and it will apply that function to all your list of inputs. So here, top level, I'm going to create a function called makeSA3map that takes a given SA4 code and SA3 data. And what it does is first filters down your SA3 data to the containing SA4. Remember, these geographic standards are hierarchical, so within each SA4 you can decompose that into SA3s. I'm going to define a color palette using the Viridis palette rather than yellow, orange, brown, and here I'm giving it a fixed domain from 95 to 115. And now I'm going to go through my leaflet algorithm, if you will. I'm going to make an SA3 level map with the CartoDB positron tiles, but otherwise this is very similar to SA4 map that I did earlier, but this is by SA3, and then I'm going to return that. Outside of the function, I'm going to be using the same color palette, and this is why I wanted to use fixed 95 to 115 rather than based on any individual values. I'm going to get a list of all the SA4 codes, so from my SA3 data, find all of the SA4 codes that are contained in it, and then I'm going to call this map function for my list of SA4 codes. I'm going to call that make SA3 map function with the auxiliary input of my SA3 data. So now, as before, I'm going to use Leaflet to create that map with CartoDB positron tiles, but here there's a slight difference in that I have this extra option that I'm going to have a pop-up graph. And I'm telling it my pop-up graph is my SA3 map list of type HTML or JavaScript, but I'm basically telling it within each element, within each polygon on my map, there's pop-up information, which is a graph, which is coming from my mapped, that's per map, that is my maps for each SA4. I have this underlying map of SA3 maps. So in doing that, this is what I get. There's SA4 map with mouse over information, but there's that pop-up difference. And so now if I click on any individual SA4 area, I get a map being my pop-up, which again is a leaflet map. I can pan, I can zoom, and this is why I wanted to use a consistent legend, so that list legend in SA3 maps the external legend in SA4, and I can look at all of these. So if I have questions about whether or not the Warrnambool and Southwest is uniform, I can see that the western area of that SA4 is doing worse. From Bendigo, I see that the Bendigo city is doing worse than the other areas. I can look at Melbourne, and there are problems in the south. And so in this way, I can add additional detail to my map because I can link HTML content or web content, Java content. I can embed web content within web content. I get this information where I can get further detail in any SA4 to look at the corresponding SA3s. And this is very powerful once you realize you can put web content in web content. Again, it doesn't work in PowerPoint, but while here I'm using maps, you could use data tables, you can have time series graphs, you can have whatever you'd like. If you're using a different web-based tool, you can embed these web-based outputs in each other. And finally, I want to note some conclusions and what you've learned. But I want to talk about what you've learned with a slight twist, because there's what you've learned, but there's also why have I presented this information to you in these formats. So if I talk about a rationale for doing this, I was invited to give a talk for Data Visualization Society, so I need to make something with data visualization. Otherwise it was open, and I chose to use maps because I've had some positive experience of stakeholders wanting to see maps. Now it needs to be 15 to 20 minutes, and that means there's not a lot of time for me to go through a lot of configurations. So here I need to decide, do I want to go hard into one part of maps? Do I want to focus on different ways you can use ggplot, or do I want to cover a number of different things like ggplot, like leaflet, like this idea of mapped maps? And the hardest part is I don't know who my stakeholders are. Now that was true when I gave my data visualization presentation, but it's even more true now. I have no idea who you are, and that means I have no idea what interests you, so I have to guess. So now I want to go through as to why I covered these different topics and what I hope you've learned from them, and the larger kind of scope of when you're using data visualizations, if you're making maps, what are the types of questions that I think you should be asking yourself. So why did I start with ggplot? Well, if you're learning R, oftentimes ggplot will be the first thing you learned. So if you're a beginner, or if you're just starting your R journey, I wanted to have ggplot so that you would be able to make a map, even if you're at the beginning of your journey. And if you need to make PowerPoint, if you need to make Word, if you need PDFs, if you need any of these static documents, ggplot is a good way to go. And it's a baseline for going to leaflet, this idea of you initialize your plot with the data. You then add different geometries to it. It's a good stepping point to say, I can do this in ggplot, and here's how that translates to leaflet. So why leaflet? Well, data journalism is growing, and this is an example from The Age, which is a Melbourne newspaper, and it's a map, and if you look down at the bottom and it says leaflet. So if you're reading the news, if you're reading a blog, and there's a map, and it says leaflet at the bottom, I want you to be able to think, I know how to make that. And finally, mapped. Well, maps is a bit of a meme, and I could say a way to scalably link data visualizations from dynamic sources, because that's kind of what I'm doing with map, but I think it's a little bit easier for you to remember if I say you can use map to put maps in your map. And I wouldn't be surprised if some of you are wondering, can I put maps in the maps in my maps? How far can I take this? And if this talk inspires you to go try it, then this talk is a success, even if, or especially if, it's to do something frivolous. And so I can make a meme out of it, but I will caution you that if you're using map to build any form of data visualization, it can be too efficient. When I say too efficient, well, what does that mean? Well, if you think back to the beginning, my data had all these different dates, and I only made a map with one of them. Well, I can make the full data set, joining my geographic information to my entire data, to my entire tidy data, so that when I have that date column, it's not just one date, but it's all dates. I can then make a function that will limit my data to any particular date and make a static map. I can then map, that's per map, to put maps in my maps, or to create this large number of maps. For each date, I can call a function and create a map. And so with 20 lines of code, when I call that, I've made 146 maps. And here they are. And I mean, if you want to see a specific date, we can go find that. We can see everything on the 14th of March is scaled to 100. Yep. We can see the onset of COVID and lockdown, and everything turns brown. And I can keep going. And what have I done? But yes, there really are 146 maps, and they're all right here. And so when you're talking about what your stakeholders want, yes, I can talk to you about how to very efficiently generate all these maps, but then displaying them gets a little tricky. It helps a little bit if I animate it, so that now rather than each individual map arranged vertically or arranged on the page, it now arranges them all in time. But again, if I'm not looking for a specific thing, what am I doing? And this is a problem that I often see between coding professionals and data visualization professionals, because if you're a coding professional, your job is largely to remove the human from the loop, to make everything work very efficiently at scale, and to make things so that everything is processed as efficiently as possible without the need for human intervention. If you're a data visualization professional, your job is to accentuate the human in the loop and build things so that the end user can see it. Now, why would I do this? Well, there's the side that says, ooh, neat, moving pictures. But otherwise, to create this type of geographic information, I could have a series of lines, one line per SA4, and have a time series that way, but you wouldn't necessarily see the interplay between regions. So Melbourne going into lockdown versus the rest of the state, for instance, if I wanted to focus on that, I would create an animated thing like this, but with a slider so that you could focus on an individual area. And to kind of finish, as a stakeholder, I'm curious to see what it is that you wanted from this. What do you want to see from Maps from R? And you may come to me with comments or questions to say, well, how do you use Python? Or how does it work with Power BI? Or I want to make individual circles like in the data journalism thing, or I want to be able to zoom in and out and change what happens, and can I put tables in my maps or maps in my tables? And my final advice to you is that it won't be what language or what tools you use or what types of data visualizations you can make, but rather how you manage all of those stakeholder requests, subject to your professional opinion as to what's important, and subject to the available data is what will make you a successful data visualization professional. If you want to get in contact with me, feel free to reach out on LinkedIn. This talk is on YouTube, but if you found this somewhere else, please feel free to come by. And all the code is again on GitHub. Thank you for your attention. Goodbye.